I feel like the man behind the curtain when somebody just pulled down the curtain. I was in the wrong scene. You could see everything. You could see all of the secret stuff. All right, now we're in the right scene. The curtain's back up. Pay no attention to the man behind the curtain. Okay, so remember we're looking at rational functions in this section. To start off, for the first couple videos, we're looking at things as simple as rational functions. And how we deal with these really depends on the degree. So in this video, we're going to say, what happens if the degree on the top is bigger than the degree on the bottom? Or at least bigger. Bigger or equal. Okay. And the short answer is just divide. That's it. Woohoo! Easy. What do I mean by that? Well, I'll show you. Example 1. Take the integral of x squared plus 3x plus 5 divided by x plus 1 dx. How do we evaluate this integral? We can't do it yet. Top doesn't even factor. Well, I'm going to follow my own instructions. We have a rational function, and the top degree is bigger or equal to the bottom degree. So let's just divide. We go off to the side. We say, okay, what happens if I take x squared plus 3x plus 5 and I divide it out by x plus 1? Long division. Whoa! Hopefully you remember how to do this. We'll do a little crash course in long division. So, what do I need to multiply this by to get rid of the x squared, to get to the x squared? Well, I have an x plus 1. If I want an x squared, they have to get multiplied by 1x. And what happens if I multiply x by x plus 1? Well, we get x squared plus x. This multiplied by that is x squared plus x. And now we subtract. X squared minus x squared cancels out. Oof. I was trying to show x, it cancels out. No, that's not what we want here. It cancels out. And then when we subtract, we have a 3x minus an x. That's 2x. And then what do we do after that? We bring down the next term. So we get 2x plus 5. And similarly, we have to ask ourselves, what do we need to multiply x plus 1 by to cancel out this 2x? Well, the answer is 2. What is 2 times x plus 1? 2x plus 2. And again, we subtract it out. 2x minus 2x, 0. 5 minus 2 is 3. And that's our remainder. So this integral is just the integral of x plus 2 plus the remainder divided by the denominator. These two things are equal to each other. We just divided it out. And when we divided it, we found out that the quotient was x plus 2, but it didn't divide perfectly. There was a remainder. So just like if you're dividing by 3 and your remainder is 2, then we have a 2/3. Just the remainder divided by the original denominator. And now we can do this integral. 1/2 x squared plus 2x. And then again, you could go around and set up a u substitution. du is dx. But for time purposes, we've done plenty of that. I'm not going to do it here. This is going to be 3 natural log of the absolute value of x plus 1 plus c. And we're done. That's a whole video? Okay, let's check our answer. That's too short. I love 5-minute videos, but you know, I don't want you guys getting spoiled. All right, so we're going to check our answer. Checking your answer is a great idea, everyone, but woo, is it fun here. All right, so we check our answer. If we take the derivative, we should get our original integrand. Derivative of this is x plus 2 plus 3 over x plus 1. Now we need a common denominator. So we multiply this by x plus 1 over x plus 1. When we do that, we have to FOIL out the numerator. X squared plus 3x plus 2. Denominator stays the same. Now we can add the numerators together because they have the same denominator. We get x squared plus 3x plus 5 over x plus 1. Oh, that really wasn't that bad. That is indeed our original integrand, the thing we were trying to take the integral of. Now, of course, this can sometimes take a long time. So this is not a proof, but if you are just doing this problem on your own and you want to check your answer, it does not prove your answer is right. But if you just want to look, what you can do is you can just graph your answer or graph your derivative. You still have to do the derivative part, right? The derivative was x plus 2. This is really a way of not checking your integral, but checking your partial fraction. Decomposition plus 3 over x plus 1. You can look at this rational function and say, well, is that the same as x squared plus 3x plus 5 over x plus 1? And you can say, whoa, orange and blue are the same. So you can kind of check your partial fractions graphically. This is a really good idea to do. All right, especially when we get to the next video. This is a 5-minute-ish. It could have been a 5-minute video. The next one cannot be a 5-minute video. Let's see what it is. It's not too bad. It's really not bad. It's just tedious. This section's just tedious, but I don't think there's anything terrible. I believe in you guys. Go ahead, get working. Let me know if you have questions, and good luck.